Hello and welcome to the fourth lesson in the Learning Python series, and this is going to be about two of the most important structures in Python as well as most programming languages, those being while and for loops. So let's take a look at while loops first. So basically when you're looking at while loops, what you're looking at is some part of a code that's going to repeat while some comparison statement is true. And when we talked about comparison statements in the previous lesson, where there's things like x is less than 10. So let's say that this comparison statement says x is less than 10. So while x is less than 10, perform these actions. And notice that we have a colon, just like we did in if statements, and then we're indenting to perform these actions. Again, same sort of a deal as if statements. So while x is less than 10, perform these actions. And that's really useful if you want to be able to repeat things. However, you have to be careful when you're doing this that you don't enter some infinite loop. So the way to avoid that is to have some way for x to no longer be less than 10. So for example, if we say while x is less than 10, perform these actions, perhaps the last step in this example could be x gets whatever x is plus 1. And the way you could write that is x plus equals 1. So that's x equals x plus 1. So at the end of this loop here, we're adding 1 to x so that I can get closer to 10. So we're saying that, for example, x could start at 0. So we're going to do while x is less than 10. We start out with 0. So 0 is less than 10. So that's good. Perform those actions. Add 1 to x. Now we have 1 is less than 10, true, and slowly we get up to 10 is less than 10. Well, 10 is not less than 10, and therefore this would break. However, if you want to break it earlier, there's the break keyword, which does exactly what you think it does. It just breaks the loop, and it has it move down to whatever code is now below this while loop. And the opposite of the break keyword is going to be the continue keyword, and rather than doing absolutely nothing, which you might think at first, the continue keyword is actually going to say, okay, we're going to keep going, we're not going to break it, however, we're going to start back at the top, and we're not going to do whatever actions are below the continued keyword. So that might be a little confusing, but we have some examples. So first, we're going to take a look at just a very simple while loop program, and we're just going to run it and see what it does. So add to the list, -1 will exit. So let's say we're going to do 9, 5, 7, and we can see that it's still going and still going, and maybe we'll add another 7. And then we'll say -1. And we can see that the sum is 28 and the average is 7. And we can very clearly see that when you're not counting -1, 9 plus 5 plus 7 plus 7 is 28. And then if you divide that by 4, which you would do for the average, you then have 7. So let's look at how we did that with a while loop. So in this program here, we're starting out with number being 0, the sum is 0.0, and the input is 0. So in the while loop, which is what we're really trying to look at here, we're saying that while this conditional statement is true, we're going to perform these actions. And we know that we want -1 to exit, which means that it makes sense to say, while the input is not -1, we're going to perform these actions. And what actions are we going to perform? Well, we can see that we're storing whatever value we give the program here in input. And then right after that, we're checking, is this input -1? If so, we're just going to break because we don't want to add -1. We want it to exit, and breaking will do that for us. However, if it's not -1, then it won't break, and it will therefore continue these actions. So what do these two lines do? Well, here we're seeing that sum equals sum plus input. And we know that when we're taking a sum of something, we want to have the total number, meaning that if we take 9, then the sum is now 9, and then we take 5. So 9, or the sum gets 9 plus 5, and then the sum is now 14. So 14 plus 7 is now 21, plus 7 is now 28. However, in Python, there's an easier way of writing this. So we can see that easier way here when we have number plus equals 1. The easier way of incrementing something is to simply do this. This is the exact same thing as what we had before, except now we're saying the sum plus equals input. So the sum of whatever it is now gets the sum plus this input. And if we look at number plus equals 1, let's ask ourselves why we might have this. Well, we're starting at number equals 0, and we know that when we're taking an average of something, we need to know the number of things that we're taking an average of. That way we can divide it by that number. So if, for instance, this while loop gets down to this part of the program, then we know that we added a number. So we would want to add 1 to 0. So here number is 1, 2, 3, 4, and then -1, it breaks before it can add to the number, so the number stays at 4. And then we can see here, this is just a simple if statement saying if they basically entered something, then we're going to print whatever the sum and the average is. And that's just printing it as we've talked about before. And that's just a really easy way of using while loops. And one of the key pieces to understand here is how to break the infinite loop. Here we're saying that if you enter -1, then this is going to break the loop. And usually when you're using while loops, you're going to have some sort of keyword like that will break their loop. So now let's talk about for loops. So for loops are very similar to while loops, except they're not exactly the same. They are going to repeat some values or some actions, whatever actions you tell it to perform here. However, it's got a little different syntax and a little different function. So we're going to write for some value in range lower bound to upper bound plus 1, perform these actions. So what does this mean? Well, it means that it's going to cycle through all of these values. So let's say that our lower bound is 0 and we give it an 11 here. So that means that from the number 0 to 11, except it doesn't perform any actions for 11, it simply stops at 11, we say for the values in range 0 to 11, which really is saying from 0 to 10, we're going to perform these actions. And whatever variable you write here, so for example, a lot of times you might write x. So for x in range 0 to 11, we're saying perform these actions. And the key part for loops is that it's doing these. You're doing this for a set number of times rather than with a while loop where you could go on essentially infinitely. So for this value, the key here is that we have a value, meaning that we give it a variable, and that variable is going to store whatever part of this range we're on. So we said before that we're going from 0 to 11. So the first pass through these actions, we say that this value is 0, and then it moves on to 1, 2, 3, 4, and so on to 10, and then it stops at 11 again because it breaks once it hits this number. And the alternative way of writing the range is that you can say the range and then the number of values that you want. So we said that we wanted 0 to 10, which is 11 values. So we would write range is 11, and the range will always start at 0 and always go to whatever the number you put in minus 1 is. That's why I do 0. That's why if we say 11, we have 0 to 10, and that's exactly what we want. So let's look at some more examples of for loops here. So here, again, we're going to run it just to see what it looks like and what it does. And we're going to say, how many values are you looking to average? Well, let's say 4, just like we did last time. So what number? Let's say 9, 5, 7, and 7. And of course, the average is 7. We know that because we already saw that in the previous program. And we already found the average using while loops, but here we're using a for loop to do the exact same thing. And that's because while and for loops can be very, very similar. And here, all we are doing differently is first we're asking them how many values they want to average instead of having them input -1 when they're done inputting values. So we're saying that the sum is 0.0, and again, we're doing sum is 0.0 as a floating point number so that it can give decimals. Here we can have an example of giving it a decimal 4, 7, 9, 6, 4, and then the average is 6.5. So we inputted 4 values, and then we got a floating point number here. And by giving the sum as a floating point number, that just allows us to print it as a floating point number, which is really cool because we don't want it to round when we're asking for an average. So now let's look at the for loop. So we're saying for x in range number. Well, we don't really care what this value is in this example. We'll look at another example where we will. So we're just going to call it x and basically never use it, and that's perfectly fine. But when we have the in range, so we also don't really care what numbers these are, so we can just put however many numbers we want there to be. So we said that we wanted 4 numbers to be averaged, and so we gave it a range of 4. That means that it's going to go through the numbers 0 through 3, and that it will pass through these actions 4 times. And these actions are basically saying add whatever we put here to the sum. And then we're going to print the average. So this is just using for loops in a very, very basic way in order to accomplish the same thing that we did with while loops. So now let's look at another example of for loops that'll show us how continue and break work. So here we're just going to run it so we can see what the output is. But now we're going to look at for loops. And this shows off another element of for loops, which is that you can put an else. So basically, if for the number in the range 1 to 11, and let's think, what does 1 to 11 mean? Well, that really means that we're using the numbers 1 to 10. If the number is 4, continue, and then print the number, and then print exited normally. So what this is saying is that it's going to run through each number 1 to 10. So we can see the numbers 1 to 10 here, except you'll actually notice that we're missing the number 4. And let's think, why might we be missing number 4? Well, if the number is 4, then we can continue. And we know that when we continue, we don't do anything below continue, we just move back up to the top. And in this case, we're going to increment the range from 4 to 5, and we will never print the number 4 because we never get to this spot. We continue from right there, move back to the top, move to 5, and then obviously 5 is not 4, and therefore it's going to print the number. And then this else statement, basically this is saying that if you run through and it never breaks, then you can run this statement. So if this never breaks, then print exited normally. And we can see that it does print exited normally. However, in this example, we do have exited normally. Or we did not exit normally because we just broke it right away. So instead, let's try to see if number equals 3 and break. Otherwise, we want to print normally. So let's see if this will run. Okay, so we see that this is running fine, except we notice that this is not exiting normally. So let's see why it might not exit normally. We have the exact same beginning, and then we're saying if the number is 3, then break. So we're not continuing anymore, we're breaking. So we did 1, it was fine, it was not 3, so it didn't break. We did 2, fine, not break, and we can see that that printed. And then 3, all of a sudden, oh, it breaks, no longer prints number, no longer goes to the top, no longer does anything, it just stops. And we can see that the else statement does not run because it did not, in fact, exit normally. We broke the statement. So that is the difference between break and continue. And that is another example of just using for statements in order to run through numbers and how you can actually use whatever number you put here. You can see that we can change this, so we can even call this x, and as long as we call x there, it will do the exact same thing right here. We can see it does 1 to exit normally. And so again, you can call this anything, and it runs through the numbers 1 to 10, not 1 to 11. Always be careful about that, which could trick you up if you're not careful. And so now let's move on to another last thing. And then this is going to be a bit of a break from for and while loops, and we're going to talk about modulus. And the reason for that will become apparent when we look at our final program. But when we talk about modulus, modulus is not only a programming thing, but it's also in math. And it's basically saying if we're dividing two things, what's the remainder? And modulus is saying it only cares about the remainder. So modulus uses a percent sign, and we say 5% 2, meaning 5 mod 2 equals 1. And we know that because 5 divided by 2 is 2 with a remainder of 1. Other examples, 8 mod 3 is 2 because 8 divided by 3 is 2 with a remainder of 2. And then 16 mod 4 is 0 because 16 over 4 is 4, and there is no remainder because 4 is divisible by 16. Or 16 is divisible by 4, therefore it is 0. And some things that you would use modulus for that are pretty useful are if you want to figure out if a number is even or odd. And the way you would do that is you'd say if a number mod 2 is 0, then it's even. And if a number mod 2 is 1, then it's odd. And we can check out a program that does this. And then the other big thing that you might want to use this for is determining if something is divisible by something else. And you could say if some dividend mod divisor is 0, it is divisible, and we can see that here. Obviously, we know that 16 is divisible by 4, and therefore it is 0, so that checks out. And if it's not 0, then it's not divisible. And we know that 8 is not divisible by 3, and that's not 0, and 5 is not divisible by 2, and that's not 0. So that checks out too. And then let's just check out a quick example of a program that does this right here, because this is incredibly easy to run, and I just want to show you an example of something you can do in Python. So let's input an integer. Let's call it 7. 7 is odd. Well, we know that's true. And then let's try an even number. 6. 6 is even. Great. So basically, this can tell you no matter what is a number even or odd, and we have just input an integer, and then if the input, the mod2 equals 0, then it's even. We talked about that before. And then otherwise, it's odd, because if something isn't divisible by 2, then it has to be odd. Okay, so now let's check out a final example that I'm just going to show you, but not really explain fully in depth. And we're just going to let it run and see what happens. So we just saw a whole lot of numbers scroll across the screen, but what are they? If you notice that these are actually all prime numbers. And what we just did here is we printed every prime number from 1 to 1,000. And there are 168 primes. You can Google it and make sure, but that is correct. And let's see how we did that. So right here, we're importing math. Basically, that's importing other functions that we can do. In idle, you can just do things like this. We'll go more in depth on this in a later lesson, but basically we're importing math so we can do things like math.square root. But you don't have to worry much about that. And then just to be simple, we printed 2 because we know 2 is prime. And that way we could start at 1 and the test is 3. And basically we're testing if something is a square root or not. And then at the end we're printing the count. And then we're also printing how many primes there are. If you want to figure out how that program works, that's great, and you really should try to understand how it works for the most part. You don't necessarily have to understand the math behind it, but you should understand how this while loop works and how this for loop works. And the reason I'm showing you this is because this uses a for loop and a while loop. This uses a while loop within a for loop, and as well as if statements and breaks, and it just shows you that you can do sort of complex functions rather easily in Python just by combining these few things that we've learned so far. And so now what I would ask you to do is to practice a bit on your own. So here are just 2 examples of things that you can do. You can say that you want to create a program that accepts some list of numbers just like we had before, and a key number like -1 or -999 that cancels the loop. And again, if you want this key number to be something that they're likely not going to use, so -999 is probably not something that they want to find the average of with something. But in this, I'm also going to see if you can find the range of the list. You should be able to do that using a lot of the information that we have so far, and you should be able to do this with a while loop. And then the other example would be to accept 2 integers and then print all numbers that are divisible by the first integer up to the second integer. If you just use a for loop, this should be pretty easy, and you should be able to do that with somewhat of ease, because for loops do a lot of the grunt work for you. They run through it, and you can use Modulus in order to do that. We talked about how to determine if something is divisible by something or not. And I would also encourage you to practice using whatever creative means you want. So for example, when I was learning about for and while loops, I wanted to create that prime number thing, and I actually made it print prime numbers up until about 4 million until my computer crashed. So maybe don't go that crazy, but it's just really fun to be able to play around with stuff. And now that we're getting into somewhat of more complex structures, you're able to do more complex functions. And I think that being able to practice and understand things is really important. So if you want to practice and understand it in ways that are fun to you, like printing 4 million prime numbers, then go for it. But that's about it for this lesson. I hope that you have a fun time practicing and are enjoying these lessons, and I will see you in the next one.